All right, so let's see if we can grasp the complexity of a social group. Now, one way to do this, and there are many, one way to do this analysis is to start with an individual. And so, over and over in this course, I'm going to start with a person, and I'm going to just draw them as a circle because I am not artistically gifted. So, okay, we can say we're going to start with you as the individual. Well, obviously, there's going to be other individuals as well, right? And we're just going to draw them as circles because I'm not gifted. And one of the things we can do is we can try and take advantage of other fields that deal with these problems. And one field is complexity theory, and in that field, they call these individuals, they call them nodes. And since complexity theorists have really done most of the work here, I'm going to defer to them and their terminology. So, all we mean by nodes is an individual. Now, if I were in another class, I might call nodes neurons. Or I might call nodes countries or whatever. But in this class, all we're just trying to say is we have a basic unit. And for us, the basic unit is going to be the individual. But if you want to research this further, we're going to call them nodes because that's what they're called in the relevant fields. So we can connect two nodes like that, and we can call these connections edges. So in this example, I have two nodes and an edge, right? Or graphically, something like that. Oh, this is where it gets so cool. It's like, awesome. I was up till 3:30 going, I can't wait to do this lecture because I really need a life. I was like, I got to lay out my shirt early. I was like, did you wear my Lucy shirt? I really need a life, don't I? I only really need to wear this like 3 times a year, okay? You know, otherwise I just look like some weird guy wearing a fossil. All right. So we have our nodes and our edges. So let's try to use this to capture the complexity. So what I can do is I can go, well, how many edges are connected to a single node? So okay, so let's talk about team social psychology. We have Alex, we have Steedy, we have myself, and we can say that, okay, here's Alex, and she is connected to two, she has 2 edges connected to her, right? Steedy, same thing. Each one of us has 2 edges connected to each one of us. So in this example, which is really, really very simple, all we would say is that Alex, she has her connections are 2 degrees. So her node has 2 degrees of connection. She has that connection and that connection. That's the degree of that node. So if we had 30 people, right? If we were connected to 30, then our degree would be 30. And this right now is sort of abstract, but immediately we can start thinking, what is the average number of connections for a group? Right? We can go, like a simplification of this problem, if you want a simplification, we could do this very easily. We can do it with your clickers, right? So if I wanted to do a simplification of the node and edge problem, I might ask you, how many close friends do you have? I mean close friends that you could call and ask for money, that you could call and say, can you hang out this evening? I really need to talk to someone, right? So we can try to figure this out. We can go, what is the average close friend? What is the degree of close friendness in our class? So we can say, okay, how many friends do you have? 0, 1, 2, 3, and 4, and more. All right, so if I were just to do this for y'all, how many friends, close friends, you can call them and ask them to help you move a body. I don't care how you think of the answer to this one. You're like, hey, I need help, there's a body in my room. Or money if that's a little more acceptable. All right, so let's go. Let's see. Keep going up. It should be on. But I see all you are giving me the same answer. Oh, I feel sad for some people. 3, 2, 1. All right, that's kind of sad. Oh, we have one. Or some people have 0. All right. If you are a 0 person, we're all going to give you a group hug at the end of this day. We can compute the average of this. In the interest of time, I can just say for our class, the average appears to be somewhere around, in the neighborhood of 3-ish, right? So we report that we have around 3 close friends that we can do this. So we can say the average degree of that node is 3. And that sort of gives us some insight into social organization. All right? But here is where it gets really cool. Here's where complexity theorists have really helped us out. Let's say that I want to really think about nodes and edges, and I say, okay, well, how many edges would there be if everyone was connected? So I have 2 nodes here. So there's my 2 nodes. And this is easy to figure out, right? I got 2 nodes. There's only one way for them to be connected. So in this case, I have degree 1. Potential degree 1, right? It's potential because that connection may not be there. All right, I got 3. This is the Alex, Steedy, and myself problem. All right, so there could be a connection there, could be a connection there, could be a connection there. 3 nodes. Oops, sorry, I don't know why they came in at the same time, but cool with me. All right, what about 4? Let's see if we can work the 4 one out together. How many possibilities are there with 4? Right, so we got our 4, right? All right, this person can be connected to that person, right? This person can be connected to that person to that person. Right? Yeah, you can have all of these connections. And so with 4 nodes, you have... Now, what does it mean to say potential degree 6? This means, let's say you're going to have a party, right? And you're going to invite people, or you're going to have a wedding. We can call this the wedding problem. Right? And you want to get a table of people sitting down, and you know this person likes this person, but they had a run-in a couple of years ago, right? But these 2 people are married. Right? So you have to understand the relationship that exists here, that exists here, that exists here, and deciding what to do. Do you invite all these people to your party? You can think of this as that kind of problem. Well, you can already see the more people involved, the more potential complexity, right? And it actually increases pretty fast. So if you continue this process, you find that it increases pretty rapidly, the complexity. All right, I don't remember how many people there were in class today. Let's see, 1, 3, 14, 20, 33. So, wow, this is going to be, I can't do this. 33. I want to see if I can predict the complexity of this room. Anyone got a calculator or their phone handy? Can do this equation? It's going to be really simple. Okay. All right, so we can figure out the potential complexity of this room. Obviously, I can't draw 33, dots everywhere, but I can figure out how complex this room might be. Okay, I need you to do 33 times 33, or 33 squared. I can't do that in my head. I want to... 1,089, okay, minus 33. 1,056. And divide that by 2.
56, not 50.
Yeah.
528.
All right. What this number here means for this classroom, there are 528 possible connections and relationships amongst the people in just this room. We're going to have a party, and I have to figure out who we're going to invite. So theoretically, I'm going to have to know all of that. That's what the equation looks like. Do you see how this gets pretty complicated pretty fast? Right? Because I have to know, all right, I want to invite you, but I also want to invite this person and you are, y'all hate each other, so okay. And imagine that's just us 3, and now it's 33 people that I would invite to my party. So the more people in the group, the much greater the potential social complexity. Now, I have the much greater the potential social complexity because I have drawn this as there are 528 possible connections, but some of them aren't going to be used, right? Like I have to know that you two don't know each other, or you two don't know each other. So now I have to go, do I invite them? Well, they don't know each other. Are they going to be awkward at my party? So what we find here is that this gets really complex really fast. So okay, if I just were to take a classic painting, and I were to go, okay, there are 14 people in this painting, even with that small of a number, that's a lot of possibilities, right? Because like maybe what I have to realize is that this is brother and sister, and you know she's staring at this guy here, but he hates this guy because he knows he used her, and you know like I don't know, and so you have to figure all this out when you're trying to plan your party. You go, who do we get together? This is complex. It only gets worse because what we actually find is other factors make this even more complex. Other factors make this where you have to go, oh my gosh, how do we ever get anything done? Because think about it. Not every connection is going to be utilized, right? Not every connection is going to be there. So it could be the case, right? Oops, sorry. That this person and this person aren't connected at all. That's a possibility. And I would have to know that. Also, the relationships between people can change, right? These two people, we can sort of work backwards. We can say, all right, these two people used to date, you know. Oops, now they don't talk anymore. The relationships can change. The relationship can be graded, right? So it's not simply present or absent, right? But I could like someone, I could like someone, I could like someone, right? And I don't really know how to draw it, but we might imagine like a chemist as a double bond, like this person is really connected to that person, right? They have a crush on them, they have the hots, they're whatever. Right? And when you're trying to figure out these social relations, right, you've all done this problem, right? Where you're trying to invite people to a party and you realize that you have to invite one person because if you invite the other, they're dating. You go, okay, if I invite Jill, I have to invite Jack, right? Oh, they got to come together. Oh, even though I really hate Jack, but Jack, whatever. I have to invite him. Let's see how else this can be complex. The strength of relationships can change over time. Right? I used to really like Jack. But I haven't talked that much these days. Why? I don't know. This is tough. How does this relate to the brain size issue? What are neurons really? Well, they're helping us figure stuff out about the world. And if we're worrying about a problem of this kind of magnitude, you're going to need a lot of neurons. And one theory here is that primates need a lot of these neurons to negotiate all of these problems. Right? Think about the problem that this chimp right here faces. This is a major problem for a chimp. This chimp here can easily kill this chimp right here. Attack him and beat him. But what does this chimp have to know? If I attack this one,
The other two are going to attack you.
well, there's actually three going to attack, right? 1, 2, 3.
Oh,
No, that's cool. I mean,
There's one back there.
yeah, there's one right here too.
Oh, I see it now.
And so when this chimp is trying to decide what it's going to do, it can't simply say, oh, I can attack and take this one. It has to go, okay, if I attack this one, I have to defend against 3, so maybe it's in my best effort to sort of call it a day. This is true for chimps. It's true for nations, right? If you wonder why we all do these pacts with other nations, it's like, okay, you can attack that nation, but if you attack them, right, if you attack this Austrian-Hungarian Empire thing, then Germany's going to get involved, France is going to get involved, and England's going to stick its nose in business. Russia's going to have something to say, and then we have what? World War I. literally have World War I.